All right. Hello, everyone. We are looking at section 7.1 in our studies this week. This represents the problems you guys are doing from that section. You're doing 7 through 18 for practice later. All right, so I'm going to go kind of fast, right? So that way the video isn't that long. However, pause as needed. And if I'm writing something down or if I have written something down, you need to be writing it down, okay? So the learning target is to understand the concept of a function, what it is. We're going to get to it. This is the definition, but you'll understand better once we go through what we're talking about. So a function is a mathematical expression or rule that defines a relationship between one variable, which is the independent variable, and exactly one other variable, which is the dependent variable. So this exactly one other is pretty key, and I'll show you later what I mean. Okay, so again, pause is needed so you can write things down, but I'm going to keep going. All right, ordered pairs can be used to show inputs and outputs. So this is really important, and then you need to be able to apply this later on into a different problem that we're going to do. So I have some ordered pairs listed here. Notice the X is the input, the Y ends up being the output. Okay, so the first number is the input, second number is the output, X and Y. Okay, so kind of related to what we've been doing before, but we're just going to focus on the input and output. But again, it'll eventually circle back to lines. Okay, so a relation pairs inputs with outputs. These relationships can be represented by ordered pairs or a mapping diagram. So here we go. We have ordered pairs, and I'm going to show you what it looks like as a mapping diagram. So this is the part where you're going to also write with me, but now we'll be pacing together. So let me go back up. I'm sorry, I'm on my end. I'm toggling back and forth here. Toggling, sorry. Okay, here we go. So, ordered pair, we're going to say is 0, 1, 1, 2, 2, 4. Okay, so a mapping diagram of this would look like we draw almost like a kind of a rounded rectangle like this, and another rounded kind of rectangle like this. And we're going to label this input, and over here output. So we have, remember, the X is the input, and it goes with 1, right? Because that's the output. That is its ordered pair. 1 goes to 2, and 2 is with 4. Okay? So the relation between the ordered pairs can be written like this as a mapping diagram, written as such. All right, so that's what that looks like. Okay, so moving on. Let's say we're given this right here, the input and output. And again, pause so you can copy, but maybe the directions will say, well, list the ordered pairs from these input-output diagrams. So the ordered pair, 1 has an output of 3. So then it's listed like this. 2 goes with 6, 3, 9, 4, and 12. So far, so good. Makes sense, right? Now, if we have something that looks like this, it may seem a little wonky, but we're still able to go match input to output and write the ordered pair. So 0, if we follow this, goes with 0. And then 2 goes with 1. 2 also goes with -2. All right, and then 4 went with -3. So we have listed the ordered pairs given the mapping diagram. I think that's what they call it for the input-output. Okay, so here is a very important note. Now that we've kind of seen how the ordered pairs can be written and then using these diagrams, the relation that pairs each input with exactly one output is a function. So this is only a function, okay? We can only determine that this is a function if each input it has exactly only one output. So if we go back and look at what we just wrote down, which one, if any, is a function? Which one is not? Well, here, each input had only one output. So this is a function. This would represent a function. Okay, looking here, 2 has an output of 1 and -2. So this is not a function. There's a relation here, but it is not a function, what we define as a function. Okay? All right, so in your practice, again, pause as needed so you can write all this down. But we have the directions. Determine whether each relation is a function. So we look here and we have -9 is 0. -2 has a 5. 5 has 10. 12 has 10. Now, this is a function, and the reason being is because each input only has one output. 12 only has 10 as its output. 5 only has 10 as its output. They can have the same output, but they can only have one output. So notice it's only one arrow leaving each of the inputs. So this one is a function. Now, if we look to this diagram over here, notice, right, all of them have just one. Oh, but when we get to 0, 0 has 5 and 6 as an output. That cannot be if we determine the relation between input and output is to produce a function. So this is not a function, not a function. We could write ordered pairs from this. We can, see the relation here is determined by what's written or given, but it's not a function. That's not the definition of a function. Okay? All right. So the other thing that you're going to come across is you are going to be given points on a coordinate graph. And you're going to determine those points on the graph, maybe these points. You have -4, 8, -2, 8, 0, 8, 6, 8. Your task is to determine, is the relation a function? So you would want to do that input-output diagram. So I'm going to create those here. Okay, so the inputs here. So what are the inputs? Those are all the x's. So -4, -2, 0, and 6. Okay, and I got that from here. -4, -2, 0, 6. And then the outputs are the y's, right? The y values, and they all happen to be 8. So we just need to write 8. So -4, 8, -2, 8, 0, 8, 6, 8. Now, it is okay that all of these all have 8 as their output. It's not one-to-one determines if it's a function. What determines if it's a function or not is if each output has one, or input has one output, and all of them only have one. Okay, so there's only one arrow drawn from the input. So then this is a function. It is a function. Okay, so if it's a function, it's going to be a line. So if you think about this, if I were to have gleaned this from a, a coordinate graph, you would have noticed it forms a line, right? So if I quick sketch, right? So if I'm at -4, let's say this is, we're going to make this a little bit taller. Let's say this is 8 up here, right? -4, 8, -2, 8, 0, 8, and then 6, 8, right? All of these are on a line. Oh, it's a function. Lines are functions. Look at that. Okay, so again, kind of goes back to this idea of our line, but we're just looking at our lines in terms of different terms and describing them differently, but all going back to our linear functions, linear systems, right? But just looking at what these different words mean and how are they related. All right, so this is all the content. Again, go back, rewatch, pause as needed. But you guys are now going to go to Big Ideas online and complete that practice that posted around, I think it was 11:30. I had it scheduled posted. So you wouldn't have seen it during SRT, but you should now see it there on Big Ideas Math. Okay. All right. Homework tonight, if you're not finished, there's only, I think, 12 problems. And I know you guys can get it done. Remember to put all of your work, everything that you've written down, created, written on paper, because I want you guys to get the practice of what we've done in the notes. You should be able to do it on paper. And really, you're just recording your answers into Big Ideas. So make sure that you're doing that and get an 80% or better. All right. If you have any questions, try to email me and I'll do the best I can to email you back within 24 hours. Take care.